So I have the two unenviable tasks. One, following Stephen Bates, number one. And number two, I'm holding you from lunch. So let's see how we can do. So we're going to kind of talk broad about the future of the data center first. And then we're going to go deep. And we're going to talk about that thing called NVM over fabrics. There's my legal. Hello. We wouldn't be Intel without having some legal. So what we're looking at right now is that there's a lot of demands on the data center. Data is everywhere. Data is exploding. I think everybody knows that here. It was interesting when I was at Amazon because we had a huge amount of data that we had to process on a daily basis, and I had to draw from, and it really brought it home to me in that particular positions that I was in. But the really interesting part is before, like 5 years, 10 years ago, most people had basically these monolithic storage networks, and then the cloud came. And they have this huge amount of public cloud that's available. And now what we're finding, and I think everybody sees this, is we're seeing this hybrid cloud area completely transform how people are looking at services, end user or customer services, and how can they make the most of their total cost in order to benefit from both public, private, and then hybrid. And it's giving users and companies a lot of choices and strategies in order to transform their businesses and meet higher and higher business objectives. So again, traditional storage, cloud storage, where the end user and business needs are seamlessly accessing data from any device at any time with the latencies that customers are expecting. I think yesterday I saw some report that Google came out and said, people, if they can't download something within 3 seconds or access something within 3 seconds, they consider it a big fail. And they will just absolutely not use that service. And this is exactly, obviously there's a lot of components to the delivery of that, but part of it is basically maximizing the amount of storage and also the benefits of storage, and that between cloud and traditional. We've seen with customers a real modernization journey, and it's continuing. We're part of the conversation, as I believe all of everybody in the room is part of the conversation. So the first part of the conversation was, you know, I've got these disk drives, and now I've got SSDs. And now I'm going and having faster SSDs and lower latencies, higher throughputs. The basic storage intelligence hasn't changed. Those are still moving forward with SSDs. Performance is increasing, and there's new storage arrays. So there's hybrid arrays and all flash. Then we see customers moving to automation. Am I going to do a scale-up architecture? Do I do a scale-out architecture? Am I hyper-converged? How much am I going to do software-defined storage? And we see customers grappling with how to build my storage data center in order to meet the business objectives that they have. And very much, I have meetings with customers all the time, and they're trying out, well, if I did this, you know, can all the components that Intel delivers and other vendors deliver, will that meet my business objectives? And I always go back and say, what to your end user are you trying to do? What workloads are you trying to drive? What is the most important thing that is stressing out that is going to make you the most money? Or conversely, how are we going to help you with cost down? And it's hopefully we can get both. We can get performance up, cost down. The last thing we see customers, and the cloud has done this very well, is developing orchestration layers, network function virtualization, software-defined infrastructure, looking at where those I/O bottlenecks are. If I solve it in one spot, basically having faster media, well, I get another bottleneck. I don't have enough connectivity. I don't have a fast enough network. I've got to go to 50 gig. I've got to go to 100 gig. In some cases, I'm hearing customers that are like, look, I want 400 gig backbone within 2 years. Okay? So that bottleneck moves. Not enough PCIe ports, but then you overwhelm the host processor. So it's basically trying to do that balancing and that trade-off on those layers. And then the last is obviously business alignment. What is going to meet the TCO needs and the business needs for that particular end user? So we have three basic things that we're driving towards. We've described it as server-based storage architectures. And basically what that means is a set of technologies that basically understand the workloads that have to run on servers and how we can be able to maximize the performance and minimize the cost for those particular workloads. And we've identified a set of workloads, and we use these technologies, which are between SSD and media, to compression, which is QAT, to new technology like Optane, which is 3D XPoint. Thank you for mentioning that a few times, Stephen. To libraries that we open source. And then the next is the media transition. We're going from disk, which is still highly viable, okay, cold storage, everyone uses it, to faster media in applications, and understanding the difference between the data tiering. So stable data versus active data, okay, and every company looks at this differently. I've been in so many companies and they say, well, the warm layer. Well, I'm like, what does the warm layer mean? What do you need for media for warm layer? And so within Intel, we've gone to describing it as active or stable. And basically understanding the service level agreements that you have internally with your customers and services and workloads on that active tier. And what does that mean? And how can the media play a part in that, but also the whole system? How does the whole system play? And the last is basically doing software-defined infrastructure. We have recently, we have software-defined infrastructure as an actual division within Intel. And basically, we are looking at building out tools and APIs and software and solutions that will help customers use software-defined infrastructure to increase their availability of services as well as decreasing their cost. And ultimately making their businesses more nimble. You can change over. As your business changes and as that cycle goes faster and faster, you need to have tools that will move things faster and faster. So the next section Niels is going to take on NVM era fabrics. This is an area that rightly, in the last presentation, the last discussion, it started a while back. My own personal was back in October. Somebody said to me, we need to run a task force on NVM era fabrics. And I thought, great, okay, let's go do this. And I had rightly and wrongly assumed that everyone knew what this was for and how it was going to be deployed and what would happen. And boy, was I wrong. What we got into was a multifaceted conversation about what are the implementations that could happen for NVM era fabrics. What problems is this solving? And we went out to talk to customers. I've been on 4 customer tours now, talking about NVM era fabrics. And I found out basically 4 things that customers are looking for NVM era fabrics to solve. Higher throughput, lower latency, lower cost, and second sources. They want to be able to move the blocks around to achieve those 4 things. And that's exactly what they're going to do. And most of these customers were cloud customers. And we have helped them to understand what are the possibilities for NVM era fabrics, what are the things that we could do, and we are now running proof of concepts internally and externally on different configurations for NVM era fabrics. So I'll let Niles take it away.
Oh, thank you, Carol. All right, I have to go on a little aside because I love that picture that Stephen Bates had of the old disk drive getting loaded into that big truck. And how many people are HDD veterans of any sort, any flavor? Oh, wow, not that many. Oh, all right. HDDs flat out have to be the most amazing multidisciplinary technology on planet Earth. I mean, the stuff that's in those things is just astounding. And if you haven't visited, up at the Computer Museum. Sorry, I didn't even know I was going to be giving a plug for the Computer Museum or the Technology Museum, or forget the name. But the one up in Mountain View, there's actually a working version of the IBM variant of that big old washing machine disk drive. And if you haven't seen it, you got to go check it out. It's pretty cool. Okay. So we came a long way from that. That old machine was probably on an IBM 360 channel. Cables about yay big around going out to the storage systems. And an old interface called count key data, which is kind of resurrecting, but that's not for this talk here. So we started off, we came up with the NVMe interface, really taking an HBA and a drive and gluing the two together. And we've got these drives across PCI Express. And the first problem statement solved. We got the fast access. We've gotten to a super high performance and a good way to get NAND up to the host. The problem statement, though, that we're following with NVMe over Fabrics is, how do we take that NVMe drive and push that out so that we can put it remotely and so that we can, in some cases, share it across multiple systems? People are looking at doing this with PCI Express, and we had a talk yesterday from DSSD, and they've got a very innovative way of taking the drives and pushing it across PCI Express and having that shared in a extremely low latency, high performance system. There's also our friends at IDT and PLX, or Microsemi and Broadcom, who are building storage switches built on PCI Express technology to kind of take that same sort of concept out to the masses. And it works. It definitely works. But PCI Express is not the best fabric. It's not the most ubiquitous fabric. Ethernet is. Sorry for anybody, the InfiniBand folks are throwing things at me right now, I can tell, and so are the Fiber Channel people. So I'll back up a little bit and say, we want to take NVMe drives, we want to push them out so they can be accessed remotely, and do it in a way that can be mixed and matched by customers and by vendors. So that's what we're doing here, and you see in the picture, we have the host software. It's the same base software for accessing a local drive. Instead of having the local drive, we move over, so if we got a laser pointer, into the channel on the left. We go across, we move from a PCI Express-based driver to a Fabrics driver, across a data center fabric to an NVM storage system, a remote NVM storage system, and that storage system presents one or more NVMe drives. The protocol is designed to be flexible enough to fit on, over a lot of different fabrics. We've got Ethernet over iWarp and Rocky, InfiniBand, Intel OmniPath, also a Fiber Channel variant, and in the future, the next generations of fabrics, the intent is to have NVMe over Fabrics run across all of those. Similar to what NVMe delivers, very low latency access to the storage and a very low overhead access to storage, NVMe over Fabrics also delivers a low access to a remote storage. Okay. Where are we at in the ecosystem? We had an industry-wide organization that was working on this, a dozen or so companies for about 18 months. The first version of the standard, the 1.0, was released on June 6th, and that's downloadable, sorry about that, in the blue text, the blue on blue that you can't read, but NVMeExpress.org, you can find the standard for NVMe over Fabrics. Linux kernel host and target drivers are available. Those can be downloaded today. And then at Intel, we have our software performance development kit, where we've taken the drivers and pulled them into user space and also built the bridge functionality that is required between NVMe over Fabrics and NVMe drives on the target side. And I'll get into that in just a couple slides or so. Okay, and that's also, the SBDK is also open sourced and available on GitHub. Okay, so again, problem statement on NVMe Express over Fabrics, NVMe over Fabrics. Take an NVMe drive, push it across to remote storage, and try to reuse as much as possible. So the majority of NVMe is leveraged for this. The host interface is the same, NVMe subsystems, the commands, the queuing model, the registry properties, power states, asynchronous events, the additional features like reservations, all of that is leveraged wholesale over at NVMe over Fabrics. And it allows you use of the common NVMe host software and also common NVMe drives on both sides of the fabric. The primary differences are in discovery and the queuing mechanisms. In this little chart here is intended to show the differences. If we look at the identifier, in a PCI Express-based drive, it's a bus device function number. Your classic PCI Express way of accessing a function on a PCI Express bus. In Fabrics, it's an NVMe qualified name. For discovery, we do bus enumeration over PCI Express, over NVMe, over Fabrics. There's a discovery controller and a discovery protocol, and I'll lightly touch on that. Queuing, in PCI Express, it's memory-based. You have a memory model of the queue, and the drive is pulling over the queue entries, and the host software is refilling them for the submission queue, reverse for the completion queue. In Fabrics, it's message-based or packetized, or in the NVMe over Fabrics nomenclature, it's a capsule that are transferred back and forth in the Fabrics. And I just noticed Bill Martin standing here in front of me, so he's going to tell me everything I said that's incorrect about the standard. Data transfers, PRPs and SGLs can be used. Either mechanism can be used in NVMe Express, in NVMe over Fabrics. No PRPs, just SGLs, and then adding in the R key for following the RDMA methodology for accessing memory. Okay, so what does a capsule look like? There's two major capsules. There's a command capsule, and the command capsule has the NVMe SQE, followed by data or an SGL, and also metadata if you have metadata that you're transferring in the command. So this is, sorry, my SCSI roots, but the immediate data concept is passed over into NVMe over Fabric. So if you have small IOs, you can have the SQE and the data following along with it, and just immediately send that out, one push command from the host out to the server. The response capsule, similar sort of configuration. There's a CQE entry, which is the exact NVMe-defined CQE, and then data following that, and again, off you go. For small transfers, that's all that's needed. For larger transfers, the SGL is passed across, and then RDMA reads and writes are used depending from, initiated from the target side to complete the IO. And then finally a CQE at the end. That's basic data transfer. Here's sort of a pictorial representation of the same thing. Shows sort of where the queues are and what capsules are passing across. We start over on the left where an NVMe command capsule is created. It's pushed across the fabric, and then it lands on an SQ in the NVMe controller on the target side. Data is pulled from one or more namespaces, and this is shown here with just namespaces, but you could also have one or more NVMe SSDs hanging off of the subsystem on the far side. The NVMe response capsule is created, and that's pushed across and lands in a completion queue on the host side. And then, as I said previously, if it is a larger transfer, RDMA reads and writes are deployed to transfer the data back and forth. Okay. So discovery and initial creation, that is new. We're not doing bus enumeration because that's PCI Express. So how does that map on, or how do we map the NVMe over Fabrics on top of a fabric? The first part is transport dependent, and you set up a connection between the host and the target, the host and the server, and that's dependent on whether you're a fiber channel, RDMA, RoCE, whatever it happens to be, that's transport dependent. Once that's complete, you issue a connect command and response to the admin queue on the discovery controller. And there's a sort of special entity, a discovery controller that's supported by the NVM subsystem on the remote side. That through that controller, you can query the controller and determine what sort of services it has, how many NVM subsystems it has, and what the properties are of those subsystems. At that point, you can connect up to each one of the subsystems that are presented by the target side. Optionally, there's an authentication step if the NVM subsystem requires it, and you need to go through an authentication step with each one of the controllers that you're talking to authenticate with the the host with the server there. Once that's done, you've set up your queues. You've got your admin queues, I/O queues set up. The I/O queues have a mapping with the connection, if that wasn't clear. So, a connection that's coming in is mapping to an I/O queue that's on one of the devices that lives on the NVM subsystem, and you're off to the races transferring data. Okay, so what are the use cases? Not intending to show the whole world of use cases here, but just some ways that we're seeing customers that are looking at NVMe over Fabrics, how they're planning to deploy it. One is a classic sort of hyper-converged or a scale-out use case. You have a bunch of servers. You need to be able to access storage on a remote server. You can use NVMe over Fabrics to be able to access that data on a remote server. Middle case, the disaggregation use case. The NVMe drives are fast and expensive. You can take those drives out, put them onto a singular chassis, and be able to access them across a fabric. And there are a number of people who are doing that today, both with NVMe over Fabrics and with some proprietary interfaces. Moving over to the right, we have the classic external storage. And a classic external storage, also called sort of the SAS replacement use case. In this case, the back-end fabric of an external storage array can be switched out from SAS to NVMe over Fabrics, and the JBODs now are the NVM subsystems presenting up the storage to the head of the array. So not intended to be exhaustive. There are a bunch of ways to use this, but this is what we're seeing from customers that we're talking to. I wanted to get drilled down a little bit more into the disaggregation use case, and then at Intel we're trying to eat our own dog food and build out a case or build out a system with NVMe over Fabrics and make sure that we've got all of the wrinkles worked out of the system. So if we look at this case here, in a disaggregated case, we have a disaggregated compute node and very thin compute node, little to no storage, maybe a boot drive, but not too much. A scalable fabric, and Ethernet with RDMA satisfies the scalable fabric. And then some disaggregated NVMe storage node. And that may have some low level of processing power, a bunch of drives on it. You can build these either capacity optimized, caching optimized, performance optimized, but point being you can build a building block for building your disaggregated system. And the model we've got here, we have capacity optimized and caching optimized. And then from there now I can scale out all the variants of my system. I can scale my compute nodes based on whatever my compute needs are. I can scale the fabric for whatever the requirements are for the fabric. And then I can independently scale out my storage, whether it's capacity optimized, performance optimized, et cetera. And going down just the next little step on what does one of these disaggregated boxes look like, nomenclature that I'm starting to use on this is we've introduced a concept of a smart JBOD. And we have some customers that are working on concepts like this where you have a large quantity of drives, but you also have a fairly high-end processor, fairly beefy processor with those drives. And in this, you have the NVMe over Fabrics, the NICs coming in to the compute engines. And what's shown here, by the way, is a dual-ported use case, but there's no direct requirement that we have a highly redundant dual-port use case with NVMe over Fabrics. You just wipe out half of that, and you have a single-ported, half-redundant system, or not redundant. So in this scenario, you have a processor, you have your NICs. The processor is running something like an SPDK, Intel SPDK, that performs the target function of NVMe over Fabrics and the bridging function to the drives. You can also add in secret sauce in this case. You can add in RAID functions, you could add in compression, you can add in some level of storage services and present that up to higher levels in the system. Also growing now and probably going to be increasing quite a bit are the bridge-based designs or sort of simple JBODs. And this is closer to our classic JBOD where you've got an FPGA, ASIC, or sometimes implemented on an RNIC, a device that does both the NVMe over Fabrics termination and then also the bridge function to NVMe, but not too much more than that. So these are going to have the higher performance, Also have the lower power, but probably less flexible and less of the higher level services. One that we're working on, at Intel, we're building up a Ceph cluster, and we have a large stack, a disaggregated Ceph cluster. So we have a large stack of servers that are supporting the Ceph object store with the Blue Store interface down to NVMe, and then across a fabric to some of our caching and or performance and capacity optimized storage blocks or NVMe subsystems. Okay, and with that, I will pass it back to Carol to wrap everything up.
Cool, thanks. Oh, thank you. So on the NVMe over Fabrics, I mean, we're having a lot of conversations with customers trying to understand different implementation strategies, different really functional and non-functional goals of what people are trying to achieve, and also put in place in items like SPDK and other elements, support for NVMe over Fabrics to support the goals of our customers. Ultimately, what we see as storage moving to is basically seamless data across clouds, whether that's private cloud, public cloud, or even within the enterprise, which is sort of a cloud in itself, and basically be able to present data and services in a seamless way. Accelerate, optimize, enable, those are basically the things that we're trying to drive with NVMe over Fabrics and other storage initiatives that we have moving along. One of them is called Storage Builders that we started last year that I think a lot of people are part of and has been highly successful. In fact, I think a lot of the personnel are outside in the mezzanine, so if you have any questions about that or anything, you can also stop by and see them. Invest, embrace, align. We believe in these three messages to basically move storage to the next generation and help companies modernize their strategies. So tonight we have a networking reception. You're all invited at the Bayshore Room from 6 to 8. So we hope to see you there and we can continue the discussion. Any questions?